Hello and welcome to the 1.5 Applying Integers lesson. Today students will be able to apply their knowledge of integers to word problems. So far we've learned what integers are, we've learned how to add them, subtract them, multiply and divide, and today we will actually use them to solve real world problems. So I just have 4 examples for you today, and the first one reads, the temperature dropped 17 degrees Fahrenheit in 6 hours. The final temperature was -3 degrees Fahrenheit. Use integer addition to find the starting temperature. Now, when I do word problems, I almost always draw a picture. We get to be a little artsy in math. And so in this problem, I might think about drawing a thermometer. Now, I'm going to draw my thermometer sideways so it looks a little bit more like a number line, but you could draw it up and down if you wanted. Okay, we know that the final temperature is -3 degrees. Okay, here's -2, -1, 0, and so on. And we could keep going. Okay, that's the final temperature. But previous to that, it had dropped 17 degrees. I need to keep going with this number line. So -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, that's good enough. I'm just going to mark 0 on here. So here's my thermometer. We're ending at -3 degrees. But think about if the temperature dropped 17 degrees, if we went backwards 17 degrees, couldn't we find out what the starting temperature was? Right? So we'd end up somewhere, hopefully in this positive area. Whatever that number is, minus, so we don't know, whatever that number is, minus 17 should equal -3. So let's just work backwards and go 17 spaces to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, and that happens to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 degrees. Okay, so that's where it actually started. So we can solve this by using a number line, or you could have written an addition problem. So you could have said, well, -3, and then if we add 17, because we went to the right 17 spaces, you could have figured out what -3 plus 17 was using your addition rules. Now they have different signs, and if you look in your booklet, your addition rules say you're going to subtract them if they have different signs. And 17 minus 3 is 14. And then it does say use the sign of the bigger number. Well, the bigger number is 17, and that's positive. So final answer, 14 degrees Fahrenheit. So it was 14 degrees, it dropped 17 degrees in temp, and it ended up at -3. Okay, next example. We have an ice cream company that reported a net profit of $24,000 in 2002 and a net loss of $11,000 in 2003. How much money or how much did the company's profits change from 2002 to 2003? So in 2002, they were doing pretty good. 2002, because they made $24,000. But in 2003, they had a loss of $11,000. So to represent this loss of money, this is a negative amount of money. So we're going to say this is a negative $11,000. So we want to know what is the change to go from 24,000 down to 11,000. Okay, what is that change? Again, I might think about using a number line, and I'm just going to do a really makeshift number line here. Here's negative 11,000. Here's maybe 0, and way up here is 24,000. Okay, this is 2002, and this was in 2003. So we want to know what is the difference between these two numbers, okay? How much space lies between them? And notice I said the word difference, okay? And difference meaning subtraction. So if I take 24,000 and I subtract this negative 11,000, that will tell me how much space lies in between them. What is the difference? Okay? Now we could use our subtraction rules, and our subtraction rules say, step 1, keep the first number. Step 2, change the subtraction sign to addition. And step 3, change the sign of the second number. Currently it's negative 11,000. We will make it positive 11,000. Okay. Step 4 says use your addition rules to solve. Well, this problem is literally just 24,000 plus 11,000, which some of us might be able to do in our heads. Some of us maybe not. So let's write it out. And I'm kind of running out of space here. 24,000 and 11,000. So I add up all my zeros. 4 plus 1 is 5. 2 plus 1 is 3. So the difference between these two numbers is $35,000. Okay, that's the change in profits between those 2 years, $35,000. In example 3, the temperature in Bar Harbor, Maine was negative 3 degrees Fahrenheit. It then dropped during the night to be 4 times as cold. What was the temperature then? Okay, we are starting at negative 3 degrees. And the problem literally says right here, 4 times as cold. So that right there should alert you that we are going to multiply by 4 to be 4 times as much. Okay, now let's use our multiplication rules. So my first question would be, do they have same signs or different signs? Well, they have different signs. This one is negative, this one is positive. And if they have different signs, you know your final answer will be negative. Okay, that's right in your booklet. Different signs, negative answer. And we know that 3 times 4 is 12. Okay, so negative 12 degrees Fahrenheit was the temperature at night. So negative 12 is 4 times as much as negative 3. Okay, we've done an addition problem, a subtraction, a multiplication, and finally we're going to end with maybe a division problem. So let's see. Angelina hiked along a 2,250-foot mountain trail. She stopped 5 times along the way to rest, walking the same distance between each stop. How far did Angelina hike before the first stop? Again, I like to draw pictures, so I might think about drawing a mountain for my picture. Okay, here's my mountain, and Angelina is starting at the bottom of the mountain way down here. Okay, she is hiking way to the top, and it says she's hiking 2,250 feet. So to go from the bottom all the way to the top, that total distance is 2,250 feet. Okay? And it says she stops 5 times along the way. So she starts her journey here, and she maybe goes up to here and stops. That's 1. 2 stops, 3 stops, 4 stops, 5 stops. Okay? So there's all of her stops. So she's got this in-between space that she's walking. Okay? And we don't know currently how much that in-between space is. But we need to find the distance, how far before she stopped the first time. So this distance right here, from her starting point to her first stop, we need to find this. Okay? So if each of these red bars, these distances, is equal, and there's 5 of them, we can just take our total distance, 2,250, and divide it evenly amongst these 5 little treks she took. So we're just going to divide it by 5 to figure out how far are each of those little treks. Okay, 2,250 divided by 5. So if we had a calculator with us, maybe I would say check your answer with a calculator, but don't use the calculator. Let's do this the longhand way. So we have 5, and I might run out of room here. Okay, 5 does not go into 2, but 5 does go into 22. In fact, it goes into 22 4 times. 4 times 5 is 20, and I subtract. So I get 0, and then 2 minus 2, or 0 is 2, and then I get a 5. Yep, and I'm running out of room. So how many times does 5 go into 25? Well, it goes into 25 5 times. So I'm going to rewrite up here. 25. Okay, and 5 times 5 is 25. And I subtract and get 0. But I still have a 0 left over. Okay, so that's just going to come up. I already got a remainder of 0, but I still had a 0 left over. So that's going to come up and be 450. So when you divide, you get 450 feet. So each one of these little treks is 450 feet, meaning the very first one is also 450 feet. Okay, that was the final example, so your homework will just be the 1.5 worksheet. Thank you.